how to use the what if analysis to change your decision boundary and recalculate profits for, let's say many different decision boundaries really instantaneously. This is a really powerful thing Excel can do and can help us pick the best decision boundary, let's say, that maximizes profits. So we'll start at the point where I've expected you've already taken the data in, you've brought it into Radiant, and you've returned the probabilities for two different models. You've returned it for this decision tree, and you've returned it for this logistic regression. The example I'm using is from our case study, so feel free to go back to that if you want to see the exact question I'm getting this from. But for the tree, I have some probabilities, and each probability corresponds to the model's estimated probability of that individual person being a buyer. And similarly, I also have a logistic regression probability that corresponds to that model's estimated probability of someone being a buyer. So the natural thing you should want to do now that we're talking about classification is we want to take these probabilities and put someone into two groups, either someone being a buyer or someone not being a buyer. Right, so we can do this. So the first thing we need to do is decide what our decision rule is going to be. For now, let's just arbitrarily say it's 15%. So I have no real reason of picking this right now, and we'll sort of make a more informed one later, but we need to start with one. So I'm going to say I'll make a different boundary for each method. So I'll say the logits. I'll make the logic cutoff. We're going to make this 1.5. So notice I'm writing it up here first. And the tree cutoff, oops. This is also going to be 15%. And we're going to use these to make a decision later. So I'm going to reference them. So I'm going to say now the tree class, right? What is my rule here? Well, I'm going to say if the tree's probability is greater than the cutoff, right? I'm going to say that person's a buyer. If it's not greater than the cutoff, they're not a buyer. Oops. And notice here that this reference, this T2, is never going to change. So let's make sure that it's a fixed reference. This is one mistake you can possibly make. But the other one is changing. So I'll just populate that for the rest of my data sets. And we could do the same exact thing for logistic regression. So the logic class. All right, this is also if this probability is greater than the cutoff, I'm going to say they're a buyer. Else they're not a buyer. And again, make sure everyone gets a nice label. Oops, actually here I made a mistake. I said this earlier, this needs to be a fixed reference. Good thing I caught that. Because again, these cutoffs aren't changing. I'm always referencing this very specific cell. Right, so this is great. So from any individual cutoff I type in here, I can recalculate these, right? So for example, if I change this to like 20, right, you can see that the values of the classes here change. We'll keep it at 15 for now, though. That's going to be important because Excel is going to go through and change these numbers later for us. So before, though, we get to that what if analysis, we're going to calculate profits, right? So the case study told us that correct classifications, right? So if we correctly identify a buyer, we earn $45, right? So we earn $45.5 for every correct buyer our models identify, but we lose $4 if we think someone's a buyer and they end up not actually buying anything. All right, so how do we code that? We're going to use a nested if statement to do this. So I'm going to say tree profits. In this case, is going to be if. So if, let's start with the tree, right? So I'm going to say if the tree thinks this person is not a buyer, so if the person thinks it's not a buyer, so if I classify them as not a buyer, I don't lose any money. I never sent them anything. However, if I think that they are a buyer, there's a couple more choices I need to make. So if I think they are a buyer, and the truth is that they are a buyer, so I'll reference where the truth is. So if the truth is that they are a buyer, I earn $45.5. But if it turns out that they're not a buyer and I sent them something, I lose $4. That's how you would write this. This is basically reads in the following way. You say, if my model choice was that they're not a buyer, I lose no money. However, if my model choice was that they are a buyer, and it turns out they truly are a buyer, I earn $45.5. However, if my model choice is that they are a buyer and it turns out they're not actually a buyer, I lose $4. You'll need to do an if statement like this on the quiz, but I'll make it pretty explicit so you don't have to get too confused about this. But this nested if statement is very important. All right, so this person earns $0, and we'll go all the way down, calculating profit for the tree. And same here, we want the logit profits, and we're going to do this in the exact same way. So we'll say if the class, if we think that if the logic regression thinks that this person is not a buyer, right? So if we think that they're not a buyer, we lose nothing. However, if the truth here is that they are a buyer, again, we earn $45.5, else we lose $4. And we'll do this again for everyone. Awesome, awesome. Let's just double check these formulas, make sure we're not doing anything crazy. They look good to me. So now from each of these, we can actually calculate the total profit, right? And the total profit is just the sum here. So I'm going to say the sum of u through u. This is going to be the profit of the tree. That's okay. Oops. So let's do u5 through, this data set goes all the way down to, let's check, all the way down to 1004. So u5 to u1004, so we don't pick up that character. Yes, can we do that? There we go, 1490. And then same here, I'm going to say I'm going to give you the sum of v5 through v1004. Right, so here's the profit for the logistic regression, given this specific cutoff. Right, so notice the couple of things that I've done here, right? The first thing I did was I hard-coded in the cutoff I wanted up here, and then I used these hard-coded cutoffs as a reference to make the classification for each model. That's very important. For each of these, I'm explicitly referencing the cutoff I want, right? Remember, I made it the right reference, so I don't make a mistake. And then for each of these, I calculated the profit, which is simply just, this nested if statement, right? Identifying the correct buyers that I found, right? And the ones that I made a mistake on. And then the profit is just the sum of that entire column. As I said in class, you want to make sure this is only done on the testing data. But to make it easy, this is already the testing data, so I've taken out the training data. And on the quiz, I will do the same thing, so you don't have to worry about it. So you can just take the sum of the entire column, but this number should only be calculated on the testing data. But I'll make sure that on the quiz, you only have the testing data, so it's not gonna be an issue. So awesome. So now we're going to do our what if analysis, right? We want to know, how does this profit change depending on how I change these cutoffs, right? So the first thing I need to do is make a table. Let's say I want to test all possible cutoffs from 1% to 99%. So I'll start with 0.01, 0.02, highlight both of these because I've established a pattern. Oops, because I've established a pattern. And then I drag this as far as I want. You can see in the bottom right, it tells me how far I'm going. I'm going to go all the way to 99. Boom. Awesome. And these are going to be the cutoffs I'm iterating over. Let's do it for logistic regression first. So logistic boundary, or I'll just say this is for logistic regression. And then right up here, right above in the next column, so one row up, one column to the right, I need to write the current profit. This is the value that's going to be returned to me in this what if analysis, and I'm going to reference it. So this is going to equal to the current logic profit, which I wrote right here. So notice I'm referencing it, right? This reference is important. I'm not hard-coded it in, and it has to go in this position. So great. So my current profit right now, without this what if analysis, is 2,102. And now what it's going to do is it's going to say, okay, well, if the boundary now was 1%, what would the profit be? And it will return that to me here. So to do that, I need to highlight this entire table and say that it is going to be my new data table. All right, so after I highlight this, I go to the data tab up here in Excel. So I go to the data tab, I click what if analysis, data table, and now it just needs to know, hey, Brad, all these probabilities here that you have, these numbers, where is that referenced in the Excel spreadsheet? And I say, well, I click column input cell. It's referenced right here in R2, and I just click that. And now what Excel is going to do is it's going to recalculate every single formula on this spreadsheet while changing this one cell. And that's why it was so important we always reference this, because it's going to change this one cell and let everything recalculate, right? Which means profit will also recalculate. That's why it's going to return to us a different profit. So I'll click OK. And there we go. Now I have the profit for every single cutoff, right? And now you can pick the cutoff that has the smallest profit. I'm sorry, the largest profit, not the smallest. That would be crazy. So you can pick the cutoff that has the largest profit. And I'll do this one more time for the tree. But as you can see, I now have profit for every single cutoff. So now we can intelligently pick the right decision boundary and pick the one that corresponds to the highest profits. Awesome, awesome. And you can use conditional formatting if you want to get colors here. So give that back, but we'll leave that out for now. So for the tree, I can do the exact same thing, right? So I can again go 1.01, 1.02, just so I can establish the pattern. Copy and paste this down. And now in this case, I'm going to reference where the profit for the tree was. So this is equal to not V3, but U3. This is where the tree profit was. And that's the only difference I'm going to have here, right? So now I'm going to highlight this entire new table that I'm going to do the what if analysis on. I'm going to click what if analysis, data table, column input cell. Now it's the tree cutoff, not the logic cutoff. So I'll click that. Okay. Boom. Now then the same thing for the tree. And again, you could pick the cutoff now that corresponds to the highest profit, which is awesome. And this is such a cool way to do something, for many different values very quickly, right? You can imagine if you were on the quiz and you didn't know how to do this, you have to do each of these by hand, which would just be insane and would take you forever. So this is a nice way for us to approach this. And so the takeaway you need to know from here is that there's a reason why we're referencing everything. Make sure the references are in the proper place, right? Make sure when you're classifying, you're referencing only one number. You're not hard coding it in, right? And then this what if analysis actually is quite easy because you can just tell it, hey, put this number in where this number is, right? And then recalculate profit. And remember, since they all depend on each other, you get this here, right? You will have to do something like this on the quiz, so make sure you can reproduce these tables really quickly. That's not going to be hard once you've practiced it a couple times. Honestly, I think it'll be second nature, and it's a really powerful and useful tool. If you have any questions, please let me know.